torsional frequency and for torque and angle of twist, because for using the Holger methods, torque and angle of twist needs to be calculated. So how we can generalize this equation for torque as well as angle of twist. Twisting alternating motion of shaft is called the torsional frequency. This occurs due to the disk mass attached to the shaft. If disk is not attached to the shaft, there won't be any torsional frequency. In fact, disk produces the torque on the shaft, and due to this, torsional frequency is generated. Mass of the shaft is neglected. Mass shaft stiffness is calculated based on the material construction of the shaft, diameter of the shaft, and length of the shaft. Shaft stiffness represents how much shaft stiff is. It is expressed as a torque required per unit angle of twist. The more the stiffness of shaft is, the more torque required to twist 1 degree of angle. For derivation purpose, let us consider three disk systems where I1, I2, I3 is a disk. Mass, moment of inertia, T1, T2, T3 is the torque, and theta 1a, theta 2a, theta 3 is the angle of twist at respective disks. K1, K2 are shaft stiffness between the shaft segments 1 and 2 and 2 and 3. Torque derivation. Let us assume a single shaft having three number of disks, which is just now seen. Mass of shaft is neglected. Mass moment of inertia we discussed. Shaft stiffness K1, K2, torsion torque T1, T2, T3, angle of twist theta 1, theta 2, theta 3, angular speed omega radian. So torque at disk 1 is equal to T1 is equal to I omega square theta 1a, equation 1, and torsional torque at disk 2 will be I1 omega square theta 1a plus I2 omega square theta 2a. So we can write T1 plus I2 omega square theta 2a. Similarly, at this 3 can be written theta 3 is equal to, T3 is equal to T2 plus I3 omega square theta 3a. So generalized equation at nth disk will be T n plus 1 is equal to Tn plus I n plus 1 into omega square into theta n plus 1. Angle of twist derivation. Equation of torsional motion for three disk system. Angular displacement in time t is omega t radian. We can write I1 into theta 1 double dot plus k1 into bracket start theta 1 minus theta 2 bracket close 0. Similarly, I2 into theta 2 double dot plus k1 into bracket start theta 1 minus theta 2 minus theta 1 bracket close plus k2 bracket start theta 2 minus theta 3 bracket close 0, and I3 theta 3 double dot plus k2 bracket start theta 3 minus theta 2 bracket close is 0, equation C. So assume the solution of the form theta 1a is equal to theta 1a into e to the power I omega t, similarly for theta 2, theta 3, and after differentiations we can write theta 1 double dot is equal to minus omega square theta 1a into e to the power I omega t, similarly for theta 2, theta 3. After replacing all the thetas, theta double dot in the equation number 4, 5, 6 and cancelling out, we can write straight theta 2a is equal to theta 1a minus t1 upon k1. So this is equation 10. Similarly from equation number 8, if you do this, theta 3 is equal to theta 2a minus t2 upon k2. So generalized equation of angle of twist at nth disk is equal to theta n plus 1 A is equal to theta Na minus Tn upon Kn. So generalized equation we know theta n plus 1 is equal to, for torque theta n plus 1 is equal to sorry Tn plus 1 is equal to Tn plus I n plus 1 into omega square theta n plus 1 A. And angle of twist theta n plus 1 A is equal to theta Na minus Tn upon Kn. So assume angle of twist is theta 1 is 1. This is the Holder's methods is used. So assume angle of twist theta 1 is 1 radian or any positive number or any number, but normally 1 is selected. Assume angular frequency omega such that final residual torque at last disk is 0 for free end shaft and final residual angle of twist is 0 for the shaft end fixed. If the above condition is satisfied, assumed angular frequency is the torsion natural frequency. Assume another higher angular frequency and check the above condition are satisfied, then there will be another torsion natural frequency, and this way higher possible torsion natural frequency are calculated, and mode shape of torsion natural frequency is plotted on length of shaft versus angular displacement. So hope we understood now how the generalized equation of torque is calculated and how generalized equation of angle of twist is calculated, because these two are very important for calculating the using calculating the torsion frequency using Holger methods. So thank you for watching.